Hello, welcome back. So let's go through the last learning objective, which is a revision of the basic integration rules involving just elementary functions. All right, so let's check what we have here. So we have a bunch of them. You have also a copy of that in the Blackboard module, so please check that out. So these two are just generic integration rules, multiplication by a constant, and then sum or difference of functions integrated. And you have the power rule for integration, you have the log rule, you have the exponential, and other exponential, and you have all trig, basic trig functions integrated here, secant and cosecant. And you have secant squared, cosecant squared, and secant u tangent u, and also cosecant u, cotangent u in 17, as you see. And the final three are the ones we have just seen in the first learning objective. So if you combine them all, this list is called the basic integration rules. So the question is, like, once you're given an integral, you first need to check if the given integral can be put in one of those forms, one of those like 20 forms here. So if you can do that by a u-substitution or by a simple algebra, then it's good because you can use the formulas to get down to the final result. So at this moment, I'm going to go over this example here because in this example we have three different integrals, and they look alike, but in fact they are not the same. And each of these integrals would give you a different result, so you're going to use a different technique to take care of each integral. All right, let's stare at the first one. The first one is dx over x radical x squared minus 1. This, in fact, resembles one of the formulas that we learned in the first learning objective. We can immediately bring that table in, or you can check from the basic integration rules. So you have du over u squared minus x squared. So if you take u to be x and a to be just 1, so u to be x and a to be 1 in the last formula, then this integral looks like an arc secant type integral. Okay, so 1 over a arc secant u over a plus c, but if you plug in a and x accordingly, so you have arc secant absolute value of x plus c. Again, we just use one of the basic integration formulas or the one in the table, which is the same as this one. Okay, we use number 20 to have this conclusion here. All right, let's look at part B. We have x dx over x squared minus 1 and the square root in the bottom. So this doesn't look like one of the formulas in the first learning objective. So this is a good u substitution problem, in fact. And you can call the u to be like x squared minus 1 because du equals 2x dx, and I do have x dx at the top here, so that can be replaced by 1/2 du. So in turn you have 1/2 du, and in the bottom you have radical u, but radical u is u to the power of 1/2, and if you look at the reciprocal of that, this is 1 over 2 u to the power of negative 1/2 du. So at this moment I can use the power rule for integration because I'm able to put this integral into one of those forms in here. In fact, it's number 4 here because I have u raised to the power of a number. That's exactly the form I have here. So 1/2 u to the negative 1/2 plus 1, negative 1/2 plus 1, that's what the power rule says, plus the integrating constant. So the bottom is just simply 1/2, okay? If you flip it over, it's 2. And you have another 1/2 here, so that's going to be 1. So in turn, I have u to the power of 1/2 plus c, and u here is x squared minus 1. So in other words, I have radical x squared minus 1 plus c as the result of part B. All right, let's stare at the last integral here. So this is dx over radical x squared minus 1. This looks like one of the forms in the first learning objective, or if you look at the basic integration formula, you have 18 here, but in the bottom you have a squared minus u squared. So a is a constant, u is the variable of the integration. So if you had that form, that would yield arc sine u over a. But in our case, it's totally different. The integration variable comes first, and then you have the constant next. So this doesn't fit in arc sine type formulation. In fact, with the techniques that we have over there, the basic integration techniques, we're not able to integrate part C, and we need newer techniques to take care of this type of integral, and that's in fact the next section. And once you start the next section, and you will see that we're going to be able to integrate this integral. All right, it's time for another practice problem. So this is already in your rest station videos. Please go ahead and try to integrate this fraction, radical x minus 2 divided by x plus 1. It's a good question because you're given a specified substitution, u equals radical x minus 2. Because as is, it's not integrable. So please go ahead and apply this u-substitution to this integral and see what kind of resulting integral you have, and you will see that you'll be able to use one of those formulas that we had discussed in the first learning objective. So please practice that, and I'll see you in another video. Bye.